Hello friends, my name is Purva Sharma, Assistant Professor of Physics at B.Sc College. In the last lecture, I discussed about the combinations of capacitors. Now, in this lecture, I am going to discuss on the topic combination of resistances. Resistance are the most commonly used electronic components. So, it is therefore useful to find the set of rules for finding the equivalent resistance in the electronic circuits. Now, resistance can be combined in two forms. First is the series and second one is the parallel combination. If I talk about series combination, then let us focus on the diagram of the series combination. In series combination, the first end of the resistance R1 is connected to the battery. The second end of the resistance R1 is connected to the first end of resistance R2. Similarly, the second end of resistance R2 is connected to the first end of resistance R3 and so on. Now, if I talk about the potential difference, then the resistance R1 will have potential difference V1, the resistance R2 will have potential difference V2 and the resistance R3 will have the potential difference V3. If next one is current. Now, if I talk about current, then the same current will flow in all the three resistance. That is, if battery is having current I, then I will flow from R1, I will flow from R2 and I will also flow from R3 and the outcoming current will also be I. So, the basic difference between the series and parallel is that in series combination, the potential difference is different in all the resistances, but the current is same in all the three resistance. Now, let us focus on the derivation of series combination. Now, according to Ohm's law, we know that if the physical condition like temperature, pressure are kept constant, then the current flowing through that conductor is proportional to the potential difference V. That is, I is proportional to V. Now Ohm's law becomes V is equals to I into R, where V is the potential difference, I is the current and R is the resistance. Now, since we are having three resistances, so we will derive the three equations for all the three resistance. For resistance R1, now for resistance R1, the Ohm's law will become, since we know that for resistance R1 the potential difference is V1 but the current is I. So, for resistance R1, V1 will be equals to I will be the same. So, V1 is equals to I and resistance is R1. So, V1 is equals to IR1. Let us give this equation as equation number second. Now, for resistance R2, if I talk about resistance R2, the potential difference across resistance R2 is V2. So, V2 is equals to I into R2. Because this I current is also flowing in resistance R2 and this I will also be flowing in resistance R3. Now, for resistance R3, the potential difference across resistance R3 is V3. So, V3 is equals to IR3. This is equation number 4. Now, total potential difference. The total potential difference is V. So, this V will be equals to the sum of all the potential difference in this electronic circuit. So, this V will be equals to the sum of V1 plus V2 plus V3. So, V is equals to V1 plus V2 plus V3. Let us give this equation as equation number 5th. Now, we will substitute all the values of V, V1, V2 and V3 in equation number 5th. That is, using equation number 1st, 2nd, 3rd and 4th in equation number 5th. So, from equation number 1st, V is equals to I into R. So, let us substitute this I into R. From equation number 2nd, V1 is equals to IR1. So, IR1 plus from equation number 3rd, V2 is equals to IR2 and from equation number 4th, V3 is equals to IR3. Now, since you can see from this equation that the current I can be common from both the side, that is left hand side and right hand side. So, I can be cancelled out from RHS and LHS. So the final equation is R is equals to R1 plus R2 plus R3. Now this is the equation when 3 resistances are connected in series. Now if there are n resistance in a circuit, then the equivalent resistance R will be equals to R1 plus R2 plus R3 plus up to Rn. This is the equation when n resistance are connected in a series combination. Now let us move to parallel combination. If I talk about parallel combination, then here you can see the diagram of parallel combination. This is the battery, this is the switch, this is the potential difference, these are the 3 resistance R1, R2 and R3 which are connected in parallel form. Now you can see that all the 3 resistance are having same potential difference, that is V, okay, and the 3 resistance will have different currents, that is the current I is coming from the battery, but this I current will get split into all the 3 branches, that is I1 will get into R1, I2 current will get into R2 and I3 current will get into R3. Now if I summarize all these, then I can see that in series combination I will be same, okay, and V will be different, okay. I will be same in all the 3 resistance and V will be different in all the 3 resistance. Now if I come to the parallel combination, what I can say is the V will be the same in all the 3 resistance and I will be different. Now let us come to the circuit. In this circuit parallel combination, the first end of resistance R1, the first end of resistance R1, the first end of resistance R2 and the first end of resistance R3 is connected to a common point, okay. Similarly, the second point of resistance R1, the second point of resistance R2 and the second point of resistance R3, they are connected to a single point, and the potential difference across the 3 resistances is V, okay. Now let us write Ohm's law. Now according to Ohm's law, V is equals to IR. Now in the case of series combination, we had written that V1 is equals to IR1, V2 is equals to IR2, V3 is equals to IR3. That means we write the Ohm's law in form of potential difference, because the potential difference was different in all the 3 resistance, but in parallel combination what is different? I is different, so I will be written as V by R. Now we will write Ohm's law for all the 3 cases in this form, okay. Now let us consider the first case, that is for the resistance R1. Now for the resistance R1, the Ohm's law will becomes, since in resistance R1 I1 current is flowing, so I1 is equals to V by R1, because V is same in all the 3 cases. So for resistance R1, I1 is equals to V by R1. For resistance R2, I2 is equals to V by R2, okay, because in resistance R2, I2 current is flowing. Now for resistance R3, I3 current is flowing, so I3 will be equals to V by R3. Now the total current in the whole circuit will be I, and this current I is the sum of I1 plus I2 plus I3, because this I current got splitted into 3 currents, that is I1, I2 and I3. So the total current will be I is equals to I1 plus I2 plus I3. This is equation number 5th. Now we will substitute the values of I, I1, I2, I3 from equation number 1st, 2nd and 3rd and 4th, okay. Now from equation number 1st, we can see that I is equals to V by R, so this will be V by R. I1 will be equals to V by R1, I2 will be equals to V by R2 and I3 will be equals to V by R3. Now you can see that V can be common from left hand side and right hand side, so these will get cancelled out from both the sides. So the equation we are left with is 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. This is the equivalent resistance when the three resistors are connected in parallel. Now, if there are n resistors which are connected in parallel, then the formula will be 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus up to 1 upon Rn. This is the equivalent resistance when n resistors are connected in parallel form. Thank you for watching this video, and please don't forget to like, share and subscribe on our YouTube channel.